Okay, so the book does a nice job of explaining about the difference between exponential growth and linear growth. We've done functions that are linear functions in the past, and now we're comparing it kind of to an exponential function. So it says Company A has 100 stores and expands by opening 50 new stores a year. Okay, so every year that goes by, they're adding 50 stores. Here's what that function looks like. It's A for Company A. 100 stores to start with and 50 for each year. So X represents the number of years going by. 10 years go by, they're going to have 500 more stores plus the 100 they started with. That'd be 600 stores. Okay, Company B has 100 stores to start with, and they're going to expand by increasing the number of stores by 50% each year. Okay, so a couple things. Here's the initial amount they're starting with, 100. You can't start out with 0 stores and expect to get anywhere if you're increasing by 50%, right? Because 50% of 0 would still be 0. Okay, so they're starting with 100 stores. And then this represents the increase, okay? Notice that they've changed it from a percent to a decimal. X still represents the time, the number of years in this case, okay? Sometimes students have questions about the 1. The 1 represents the 100 stores that you started with, right? Okay, so you're still going to have 100 stores after, 0 years go by. And then 1 year goes by, you're going to have 100 stores plus 50% of 100, okay? So you have to have that 1 there or you wouldn't have the initial number of stores. Okay, so I'm going to try to scroll up. Last time I did this, it didn't work, so we'll see. Scroll up. And they give us this chart. Now, they gave us the functions. We're not going to do the work. We're going to use this table and let them do the calculations this time. Okay, so here's Company A. They're the ones that are adding 50 stores every year. No years go by, still have 100. 1 year goes by, 150. 2 years go by, 200 stores. 3 years go by, 250. Notice that it's increasing by 50 stores each year. Okay, now let's look at Company. Well, let's graph that. Okay. So we're having 1 year, 2 year, 3 year. Oh, yeah, that's it. Okay, so this is going to be the years. And then let's see. We'll go 100 stores, 200 stores, 300 stores, 400 stores. So I'll count by 400. Okay, so when we were at 0 stores, we had 0 and we had 100 stores right there. Then 1 year went by and we had 150 stores. And then 2 years went by, we had 200 stores. And 300 years went by, we had 250. This is linear. Well, me trying to draw a line. Okay. Now, what happens for Company B that's going to increase by 50%? They're still starting with 100 years. The starting place is still the same. And then after 1 year, they're at 150. That's the same as the other store, right? Now, something's actually occurring between 0 and 1, and we'll see that when we go to graph this. But now let's see what happens at 2 years. It's up to 225, whereas the other store was at 200. So maybe it's up there. And then what's happening here at 3 years? Well, it's up to like 337.5. So it's going to be up, around here someplace. Whoops. Around there someplace. And so now we have this type of curve for an exponential function. Notice, well, something like that. It's got a little change here. We're not going to talk about that right now. Mostly what we're interested in is how quickly this is going to go up compared to the linear function. So, but that's what the graphs look like. It's hard to see that little gap that I've drawn there in the book, but it exists. If you were to graph these, you would see that. Okay, so that's just a little more explanation about how a linear function differs from an exponential growth function.